Good morning students. In last class already we are completed about magnetic induction concept. In this class we are ready to discussing about axial line and equatorial line of a bar magnet. See students, in each and every bar magnet compulsory two different unlike poles are present. One is north pole and another one is south pole. The two poles are separated by a certain distance. The distance only, or the distance between those two unlike poles only, were taken as magnetic length. So magnetic length is represented in terms of 2L only we are representing. So in this class we want to discuss about first of all axial line, and one more thing is equatorial line. See here students, one small diagram I am represented. So just we will go for that diagram here. This is one bar magnet I am representing. Let this is north pole and this one is the south pole. These two poles are separated by a distance of 2L. If suppose a line is passing from both the poles, means that line only we are calling as axial line. Means the line passing through north and south poles of a magnet is known as the axial line of the magnet. Next, one more thing we want to discuss, that is nothing but about equatorial line. See students, we want to discuss equatorial line means, see this is the midpoint of the given bar magnet. The line which is passing through that midpoint and perpendicular to this axial line, so that line only we are calling as equatorial line. See, the line which is passing through center of the magnet and perpendicular to the axial line only we are calling as what here, equatorial line. Okay students, so we are getting one clarity about axial line and equatorial line. Axial line means that is passes from both the poles present in a bar magnet, and equatorial line means the line which is passing through center of the bar magnet and perpendicular to axial line. These are the things. Students, few different formulas we are ready to observing here. Just I am mentioning here only the formulas, so I am not ready to discussing about the proofs. So just go through these formulas. First one, magnetic induction at a point on axial line of a bar magnet. For this one we want to recollect one formula. See, at a one point on axial line, that magnetic induction value is how much? That is we want to observe here. See, let this is one bar magnet, this is south pole, this is another north pole. So the line which is passing both this means this is we are treated as axial line. This is axial line. On this axial line we are choosing one point P here. So this is north pole, here unit north pole is present, so in this direction B will be acting, so away from the north pole is B is acting. See students, here we are maintaining some distances. This is the midpoint O is present, so total length is 2L. Here L is present, here L is present students. Let observe carefully, from center of the magnet to this point how much distance is present? Small d distance is present. How much distance is present? Small d distance is present. One more thing students, for this thing, magnetic moment is we are taken as a small m into 2L. Small m is we are taken as the pole strength, and 2L is we are taken as the length of the magnet. Okay students, then what is the general formula here we are getting means, B axial value is equal to preferable value mu naught by 4 pi into 2 into capital M D divided by D square minus L square whole square. Like that we will represent. What is the formula? B axial is equal to mu naught by 4 pi into 2 into capital M into D divided by D square minus L square whole square is the formula. So one small application we are observing here. If suppose L is very less than D, in that condition, in denominator already we have D square minus L square. So that D square minus L square just you can taken as only here D square only. D square minus L square is approximately we are taken as a D square. So this one we are substituted in above equation means, on simplification we will get on axial line magnetic induction is, that is B axial is equal to mu naught by 4 pi into 2 into capital M divided by d cube. What is the formula, students? P axial is equal to mu naught by 4 pi into 2m divided by d cube. This is the one formula we have. Okay, students. Then we will go for magnetic induction at a point on equatorial line. We will discuss now. Listen, students, this is one simple thing. Magnetic induction at a point on equatorial line of a bar magnet. Let first of all I am representing here, this is a bar magnet having length 2L. This is the south pole and this one is the north pole. Here one unit north pole is present on equatorial line. So for example, this is we are maintaining a distance d, so this one is becomes L. Ultimately this is acts as one side of the triangle. That length is equal to root over d square minus L square by Pythagoras theorem. Similarly, here also we will get root over d square minus d square plus L square only, that is also from Pythagoras theorem only. So here we are maintaining at a distance d. In this situation, B equatorial is equal to, we are directly representing as mu naught by 4 pi into m divided by d square plus L square whole power 3 by 2. So that is the formula, students. B equatorial is equal to mu naught by 4 pi into m divided by d square plus L square whole power 3 by 2. So in case of short bar magnet, we are representing d square plus L square is approximately equal to d square. So finally, B equatorial is equal to mu naught by 4 pi into m divided by d square whole power 3 by 2. On simplification, we are getting B equatorial is equal to mu naught by 4 pi into m divided by d cube. So B equatorial is equal to how much, students? Mu naught by 4 pi into m divided by d cube only we are getting. So how we are getting these proofs means, in previous classes, especially in electrostatics, about dipole already we are taught. That is nothing but electric dipole only we are already discussed. In case of electric dipole also we are identified this type of rotations on axial lines and equatorial lines. In that condition, electric field intensities proofs we have. Okay, in the similar manner, these proofs also we can identify. So this electric dipole and this bar magnet or magnetic dipole are resemblance as same only. This is the last and final case, students. Magnetic conduction at a point due to magnetic dipole. Means now in this situation we are not taking that point on axial line and we are not taking that point P on equatorial line. At any other point we are taking. Just observe carefully, students. This is initially on magnet is present. So this is I am taken as a south pole and this one is taken as a north pole. Here away from this north pole, here M will be acting. So this one is present like this, means just we are maintaining here on point P, maintains at a distance D also we are maintaining from the center. Actually this is we are taken as a center, this distance only we are taken as a D like this. Okay, students. See, in this situation what happened means that magnet is considered into two ways. So the magnet ns of magnetic moment N can be treated as a combination of two magnets. So here first magnet is N1 S1 we are represented here. From that one some B1 is coming like this, magnetic conduction. So and one more thing is, this is N2 S2, another magnet is present in this direction. Actually B2 is present. This B2 only we are representing like this. Is it clear, students? Now what the thing happen means, along this one, which one is present? Axial line is present. So in this condition we are getting as here m cos theta we are identified. Along from second magnet we are getting m sin theta by which one? Resolution of vector condition. So actually this is m means along this direction m cos theta we are getting, and along this side we are getting as m sin theta, students. Here m cos theta and m sin theta are what the thing is present, students? Perpendicular to each other only. So how we are getting the result once here? How we are getting the result now? Once we can think it, students. From N1 S1, here the point is acts an axial line. So axial line notation we people know that is mu naught by 4 pi into 2m cos theta divided by d cube. This notation previously we people know, students. In the similar manner, okay, from n to s to magnet b2 value is equal to mu naught by 4 pi into m sin theta by d cube. Let this is equation 1 and this is equation 2. Here b1 and b2 are perpendicular to each other in previous diagram. Both are perpendicular to each other means resultant becomes how much, students? Resultant is becomes b value is equal to root over b1 square plus b2 square. By substituting equation 1 and equation 2 in this equation, finally we will get as mu naught by 4 pi into m divided by d cube into root over 1 plus 3 cos square theta. Like this we will get one notation, students. Okay, students. So here p value is equal to mu naught by 4 pi into m divided by d cube root over 1 plus 3 cos square theta. See, students, if suppose theta value is 0, we are substituted means that is axis axial line, we are getting mu naught by 4 pi to 2m divided by d cube. If theta is equal to 90 degrees means we will get on equatorial line, so therefore b equatorial is equal to mu naught by 4 pi into m divided by d cube. These are the simple relations we have. Based on these formulas, now I am starting a few problems for you. So next exam, okay, coming weekend, okay, based on this syllabus only we are ready to conduct a few exams and few things also. Just we will go through few problems now. Okay, students. See, students, this is one simple problem for you. A straight magnetized wire of magnet, okay, moment capital M is bent at the middle so that the two parts are at an angle of 60 degrees with each other. The new magnetic moment we want to find. Let students one thing, this is initially one magnet is present like this. Okay, students, let I am taking this is the north pole and this one is the south pole. Here this one is totally 2l length is present. This magnetic moment is capital M is present like this. This one is bended like this. Bended like this means we may get like this. Okay, students, this is the representing diagram. This is the north pole now becomes here. This one is south pole. Here how much angle is present? 60 degrees is present. Actually total length is 2l. This is a midpoint, so this value is l. We may imagine here this value is also becomes l only. So students, now here we are bending at midpoint means we have one formula, that is new magnetic moment. New magnetic moment having one standard formula. Midpoint, at midpoint we are bending means that is I am taking m dash is equal to m into sin theta by 2. Okay, students. So here m dash is equal to m is nothing but initial or original magnetic moment. This is sin. Here angle how much is we are observing? 60 degrees. So here 60 degrees divided by 2. Therefore m dash is equal to m sin 30 degrees. So students, on simplification, m dash is equal to m divided by 2 only, since we know sin 30 degrees value is equal to half. Okay, students, this is the result. So new magnetic moment when bending at a center by making an angle 60 degrees means resultant is becomes m by 2 only. Okay, students. This is one more simple problem, students. Just observe carefully. This is actually in your prescribed syllabus 5th problem. The resultant magnetic moment for the following arrangement is, here observe carefully, this is 1m, here this is another m, this is another m. Here clearly mention 90 degrees. For observing condition, here I am drawing one more time this same diagram here. So this is m, this is also m, and this one is also becomes m only. Here 90 degrees is present. So let I am taking this one is m1 and this one is m2. I am taking, students. m1 and m2 are perpendicular to each other. So ultimately in this direction resultant thing we are getting. So this is I think m dash. M dash is equal to, first we will find out. So I am mentioning here, students, m1 and m2 are perpendicular. Perpendicular means m dash is equal to root over m1 square plus m2 square. So here root over m square plus m square we will get, so root over 2m square we will get. This is nothing but root 2 m we are finding. See students, this value is equal, we are identified as a root 2 m we are identified. So observe things students, this root 2m and this m are in which directions? Opposite directions. Let therefore here in diagram root 2m and m are in opposite directions. Opposite directions we are representing. So therefore final resultant or m resultant is equal to your greater minus least values we can take in. So which is greater value? Root 2m is greater value and least value is m, or simply we will represent m dash minus m, that is nothing but root 2m minus m only. So by taking here m common, therefore we are getting root 2 minus 1. So therefore m resultant is equal to, here we are getting as m times of root 2 minus 1. Like this easily we can find. This is the simple solution for you. Okay students. Now this is one more problem students, just observe carefully. The resultant magnetic moment for the following arrangement is, this is the given thing, this is m, and m is present, but here 120 degrees, here also clearly mentioned 120 degrees. Now I am rearranging this diagram like this. See, this is the diagram we are taken, this is m, this one also m, here also m is present, here 120 degrees is given, here also 120 degrees. So students observe carefully, this m and this m makes 120 degrees each other. So in this direction we are getting one resultant value, or let this is m dash. So we have here like poles touches. Like pole touches means what the thing we have the formula m dash value is equal to root over, we can able to write as m1 square plus m2 square plus 2m1 m2 cos theta. That is the standard formula students. Therefore here m1 is equal to root over, here m square plus m square plus 2m square cos 120 degrees I am mentioned here. So then we will going further means m dash value is equal to root over m square plus 2m square cos 120 value is nothing but minus half. So this is 2 and this 2 will be cancelled. This is plus m square, this is minus m square cancelled. Finally m dash is equal, we got here m only. So this is m value we are newly finded here. So one thing students, this m and this m are in opposite directions. Now m and m are in opposite. Opposite means now we are going resultant value as m resultant is equal to, here I am writing here m dash difference m, nothing but m difference m. Finally here m resultant value is becomes 0. So resultant magnetic moment is becomes here 0 only. Okay students, all are understood this simple problem? Okay. Okay students, one more problem now we will think it. A thin bar magnet of length L means, let this is one bar magnet is given students. Let I am taking this is maybe north pole is present and this one is north pole, but here L only length is given, okay, not 2L. And magnetic moment for this one, here magnetic moment is how much is given, M is given, okay, is bent at the midpoint so that the two parts are at right angles. Means let I am taking this entire magnet is bent like this. Okay students, here length is becomes L by 2, this is L by 2. Actually this is north pole is present, here south pole is present, here 90 degrees is present. So next continuation, now new magnetic length and magnetic moment are respectively. So here 90 degrees clearly we know students. So this is actually line joining. From Pythagoras theorem, if you are observed means, let I am taking this is x, therefore x value is equal to by Pythagoras theorem root over L by 2 whole square plus L by 2 whole square. So x value is equal to root over 2 into L square by 4 we are getting. So this one 2 here 2 times cancel. Finally L divided by root 2. So therefore this value is equal to new magnetic length is becomes L divided by root 2 we are identified. So here one more thing, new magnetic moment. Okay, new magnetic moment, we have formula when bent at midpoint makes an angle theta, means that is m dash is equal to m into sine theta by 2. We people known students. So here theta is equal to how much, or angle is equal to how much is given, 90 degrees is given. So therefore m dash is equal to m sine here 90 degrees by 2, that is m sine 45 degrees. So therefore m dash value is equal to, we can write them as m divided by root 2. Since sine 45 degrees is equal to how much, 1 by root 2 is the value for sine 45 degrees. Okay students, listen students, this is one more problem. I am ready to solving this problem, so listen carefully. A magnet of magnetic moment m of and length 22 centimeters is given. Okay, is bent into a semicircle, is given. Now the new magnetic moment is here, new magnetic moment that fellow is expecting. So here observe carefully, this is initially one bar magnet is present, this magnetic moment m. Now this one is bent into like this, in this way. This one is bended. Let this is a north pole and this one is south pole. Maybe this is a north pole here and this one is south pole. See students, here at center how much angle maintained, 180 degrees or pi radians, or theta is equal to pi is equal to or 180 degrees is clearly mentioned. In this situation m dash or new magnetic moment is equal to how much is expecting. So in the form of arc shape bended means that m dash is becomes 2m into sine theta by 2 whole divided by theta. So compulsory here theta in radians only. In theory class clearly we are mentioned that one. So m dash is equal to 2m sine pi by 2 whole divided by pi. Okay students, here we will mention this one, m dash is equal to 2m divided by pi only. We will get it, since here sine pi by 2 are nothing but sine 90 degrees value is equal to 1. So this is a 2m divided by, okay, pi value we are mentioned students. And also one more thing, m dash is equal to 2m divided by, instead of pi can I represent it 22 by 7. So therefore on simplification here 2 into 7m divided by 22 we will get it. Okay, this 2 here how many times, 11 times cancel. Finally m dash value is equal to 7m divided by 11. So how much we are identified, new magnetic moment, 7m divided by 11 is the result we have. Okay students, so in next class we will go for remaining problems based on the concept of inverse square law and magnetic fields. Okay students, thank you.